The force of gravity, the normal force, a surface pushed back. What is the free body diagram? That means the finding the total force on a body. Now we describe the weight, the force, that means the gravity, the force of gravity. Newton introduced the idea of gravitational force to explain the Galileo's natural downward acceleration. Previously, forces was only used to describe the direct physical contact forces. The idea of the gravitational force seemed weird, kind of the irrational and magical. Weight and inertial mass, all falling objects have the same acceleration when air resistance is eliminated. So applying F is equal to ma, or a is the acceleration of the matter of the objects, that is the here when you talk about the m is the weight, that is the m is equal to mg. The gravitational force on an object, its weight must be directly proportional to the initial mass. That means the weight must be directly proportional to the initial mass. It is obvious why this should be true. If the object is taken to the moon, its initial mass does not change. It takes the same energy to accelerate a car, but its weight does change. Now, this is the Newton's second motion of law. First is inertia rule. Second is F is equal to ma, force rule, and third is the action and reaction. Now talking about the normal force. Right now the force of gravity is pulling us all downward, but we are not moving. What about F is equal to mg? Then remember, F is the total mass on the body. If the floor disappears, I will accelerate downward. If floor on which we are stand or walk or travel, if it disappears, I will accelerate downwards. The normal force that is summarized that a floor is providing the force balancing that of gravity. It is called the normal force. And now arising the questions: how can something as inert and immovable as the floor provide a force? Clue is clue. How does a spring balance provide a force to measure a weight? Now talking about the normal force and springiness. When the tomatoes are put on the scale, it moves down, compressing a spring until a spring's force balances gravity. The floor is elastic too. Where you stand, it sags a little and push back like a very stiff spring. Now arising the questions: I stand on the ruler, sketch facing a wall. I reach out, a push against the wall. I accelerate backwards. What force caused my accelerates? Option is my arm and back muscle, my push against the wall, the normal force from the wall, the friction between the skates and the floor. And second question for you: what is the normal force from the elevator floor on the person waiting mg? If the elevator is accelerating up to at 0.1 g, and your option is 1.1 mg and 0.9 mg, and none of the above options. Now this answer will give in the next videos. Here we describe the tension in Newton's original statement of his third law. It features a horse pulling a rope attached to a stone. A tension in the string means that if the stone is subjected to certain force from the horse efforts, the horse feels an equal and opposite force from the tag of the string. The string is pulling inward at the both ends. Tension puzzle: a 1 kg mass hangs from the string. The other end is looped over the hook. Suppose a looped end of the string is taken from the hook, but over the pulley and a 1 kg mass is hung from that into what will be the spring scale now? About the same, about the double. Think about it. And now talking about the free body diagrams, to apply the Newton's law and to find how the body moves, we must focus on that the body alone and add all the vector force acting on it. The diagram shows all the forces on one body or even part of a body is called the free body diagram. We have freed the body from the rest of the system, representing everything else just by force of the body. The neutral force then goes into the summation of F is equal to ma. So we can summarize all the topics at the end of this video as the Newton's 3 law of motion. First is inertia. According to it, any body which have still in its state. That means if any body which have in a moving flow, then it will be try to remain its states without where it's not applied any external force. And the second law is, and the second force rule, it is called Newton's second force rule, that is that the force acting on the force on the objects is proportional to the mass of the objects. And the third action and reaction, that is when we post any object, it will also be repelled to upward. Thank you.